What's going on, everybody? This is Future Automation, a place where imagination meets reality, and you're listening to Tejas. Welcome to another episode of Arduino series, the start of IoT. And today we are going to learn about analog functions with a cup of coffee. Let's get started. So, before going into the actual coding and explanation part, today I'll show you what exactly we are going to see at the end of the video. By the end of the video, what we are going to do. So, let me just dim the light a little bit so that you can see it. So, yep, that's what we are going to do today. So, but again, the explanation of these things will not be done because that is part of the next video where we are going to cover the basics of other things which are related to IoT, maybe revolving around the Arduino or maybe revolving around the projects that we are going to do. So, the target for today is that what we are going to understand is how analog read and analog write works for us and where we can use that. So, let's get to it. So I have the new code open here, and before that I'll bring in a little bit of theory again. This time I'm not going to show up any presentations and all, just a quick information about what two functions we are reading here. If you'll go to the Arduino documentation, which I'll link in the description, you'll get all the information about what these functions are and what other functions are also. If you see here in the references, you can see what is digital part, what is analog part. We have 0, DUE and MKR families, IO, advanced IO, math, trigonometry, characteristics, and a lot of things. We can also communicate with the computer as a mouse or keyboard. So that is a whole lot of another project that we are going to do in future, but as of now I need you to understand the basics of these two analog functions. So let's go first with the analog read. Now, this part is something that we are going to extensively use a lot because a lot of times the function, the sensors which are having analog values are sending the data in analog form where we don't have zeros and ones, but we have a value that ranges from 0 to 1023. So that is around 1024 units or 5 volts. But again, it varies. So the different voltage that we are getting, we are converting it into units and we are getting that value from Arduino. Now, different Arduino boards or different boards, as a matter of fact, have different number of analog inputs. But for us, we have 5 analog pins in Arduino A0 to A4, sorry, A5, which is 6 analog inputs which we are going to use today, one of out of that. So basically analog read, what it does is it reads the value of an analog sensor and it shows that value, or we can use that value, or we can map that value with the output that we are expecting. So when we say output, that is where we are going to use analog write today. Although analog write is something that we only use when we want to use PWM, that is pulse width modulation. The idea is that when you want to send a wave of frequency or a wave of voltage to something as a part of output, for the example that we are going to use today is an LED, that's where you go with analog write, because digital write is only responsible for 0 and 1, that is either high or low. So there you cannot send a, a wave of frequency, rather you can save just high or low. But analog write sends a wave of frequency based on the data that we are providing from the analog read again, and that is how it works. So pulse width modulation again is specific to only specific pins that are mentioned again in this chart. You can read this when you check out the website. I'll link the whole thing in the description. I'll link this main website only so that you can use that. But here you can see for Uno, Nano, and Mini, the pins that are having the capacity or the capability of pulse width modulation are 3, 5, 6, 9, 10, 11. Now, going back to the board, if you'll see the board here, I can show you in the board, you can see here that some pins have dots in front of them in the digital IO. You can see here we have 3, we have 5, 6, 9, 10, 11. So these are the pins that are having the ability of pulse width modulation. So in these pins, we can send the wave of analog right, and then you can use that data to control the brightness of LED and many more applications we might have. But that is one thing. Now, for analog read, we have the values that are ranging from 0 to 1023. But for analog write, we have the values that are ranging from 0 to 255, which is again I'll always on for 255, and for 0 it will be always off. So these are the duty cycles that are running through this pin to control the brightness of LED in our example again. Now, what are the basics of voltage, current, and resistance, jumper cables, connection basics, breadboard basics, LED basics, potentiometers, sensors and actuator basics, and parallel series basics are something that we'll try to cover in the next video, because a whole lot of things are involved in that, and a big video is required to cover all this. As of now, I want to give you the basics of Arduino, and then we'll go and cover the things that are revolving around Arduino or other boards, as a matter of fact. Now, going to the code part. So I have already kept a function ready here, uh, a new program ready here, and what we are going to do is we are going to start first with the analog read, because I want to show you how it reads the analog values, and then we'll go to the final program, which is something where we are going to do the same thing again, and I'll explain you the program at that time. So to see the analog read values again, what we can do is we'll create a variable here, which is int analog pin equals to A0. Now all the analog pins are represented by A in the starting and then the number of the pin. For digital, what we did was like 8, 9, 10, 11, 12, 13. But here, to make sure that the controller and the ID understands that this pin is an analog pin, we are representing it as A0. So A0 to A5, since it is starting from 0. So we have 6 pins. And then what we need is int val, which will be a variable to get the values of the sensor or the potentiometer in our case. And then what we'll do is we'll write serial begin, and since we want to see what data exactly is coming in, we are using serial begin. And then after that, so here we are only concerned with the serial begin. Next to that, what we'll do is I'll just get this down for us to see. Okay, and then next to that, what we'll do is val equals to analog dot read, sorry, my bad, analog read, gee, read, and then we'll give here the analog pin. So if I'll call for the auto complete, it'll fill in the variable that we have created, and then serial dot print ln, because we want to print everything in the next line. That will be really great of reading, and val. And yep, that's it. That's the basic code that we need to, read the analog values. And if we'll pull the serial monitor up and run the code, let's run it, and hopefully it should work. So uploading is completed. And if we'll, you can see it's 0, but if I'll increase it, you can see that it is increasing the value slowly, and it will go up to around 1020 in range. Since we have some noise in the connections and in the sensors, it might vary a bit, but you can say 5 or 10 units front or back. So you can see here from 0 to 1015. And here, if I'll try to see if we can plot the data, but I'm not sure. So okay, the monitor is open this side, so let me just bring it here, and you can see that we are able to plot the data here. And if I'm going to reduce it, you can see the whole plot changes with this. Now these things are really useful when you want to debug your connection or debug your project here. And you can see that this really helps you a lot to understand how things are going on within the board or within the sensor and within the potentiometer or within how the current is flowing. So this is how powerful this whole ID or this whole Arduino project is. And now you can understand what exactly we can do with more sensors or more project ideas coming in. So this is what the serial analog read function was. And now we are going to come to the final code, which is, let me just bring in the code. So here, I was not hoping to put too much time in writing the code, so I've already written the code. And what it does is, I'll show you in a minute. Now, y- you can see that there are few things that are added right now here. So first I'll explain you the code, and then we'll go to the uh, connection part. Okay, guys. So looking at the code, we can see that we have done some initialization in the beginning, and then we have done a white setup, and then we have a white loop function part, which is almost around 15 lines of code, if you'll say, including the brackets and the spaces. So first, what we have did is we have connected the LED to pin 9, and then we have connected the analog pin, that is the potentiometer, to A0. So that are the variables that we have initialized. And then we have set up a pin mode for the LED pin to output, because we need to again get the LED act as as output for changing the brightness. And then we have we have created a sensor value here, which reads the analog value using analog read. Now here, as I explained in the previous part of analog read, that we are reading the analog value which varies from 0 to 1023, which can vary from around plus or minus 10 based on the noise and the potentiometer or the sensor that you are using. But the standard values vary from 0 to 123. And then what we are doing, it we are adding it in the sensor value variable. Now we are using the same sensor value variable in another function, which is map. Now, what does map does is, map will map these two values with these two values and give it into the variable which is brightness. Now, since we need the brightness of the LED with a variable from ranging from 0 to 255, because we are doing the analog write part with a value of 0 to 255, it is the duty cycle, the wave in which we are passing the voltage. And because of that, and since we cannot do this whole thing in a in a in a very easiest manner, we have to create a complex function. They have already did it. So we have a map function where we are using the actual sensor value from ranging from 0 to 1023, and then mapping it with 0 to 25. So this sensor value will be mapped from this to this. So if we'll check this function in the in the uh, in the details, we can get what all values actually are being passed. Now this brightness that we are getting, the final output, what we are doing it is we are passing it to the LED pin 9, and we are adding the amount of brightness, that is the number of duty cycles being passed with analog write. Now the reason we are using analog write is because to send a pulse with modulation signal to that particular pin, which is pin number 9, and this pin is basically a PWM capable pin. That's why we are using that. And as I explained in the previous part, that we have few pins in each board which are dedicated for PWM signal. Now let's go to the board and see how the connections are being made here. So you can see here that LED is having two pins which are connected to ground and pin number 9. So if we'll see the board here, let me just try to zoom in a bit, or maybe we can take it a little bit close. And you can see here that the pin is connected to pin 9, the LED pin, and then we have connected one to the ground. Now these pins are connected back to the LED, and then I have connected one potentiometer. So basically the work of the potentiometer is to give you a variable resistance which will go. And now we have different potentiometers with different resistors values. What are resistors, what is resistance, we are going to cover in the next video, where we'll be covering most of the basics of electronics and different things that are revolving around the Arduino. So we're not going to go much into deep, but the idea here is that when you're going to turn the knob, it will change the value of the resistance, and based on that value, what we are going to do is we are going to increase the brightness of the LED. Now if you see the potentiometer, then I'll just now if you see the potentiometer here, you can see that the potentiometer is connected to A0 at this point. These are the five analog pins, six analog pins here. So one cable, that is one jumper cable, is connected to A0, and two are connected to ground and VCC. So the A0 pin is taking care of reading the analog values. Now let's run the code, burn it on the microcontroller, and see if it works or not. So we'll upload the code here. Now the code is uploaded. So let's see. I'll decrease the brightness of the light a little bit to see if the LED is getting burned or not. So if you can see here, the LED brightness is being controlled with the potentiometer. If I'll zoom in a little bit, then I think you'll be able to see a little bit better. So that is how we are working with the potentiometer and LED using analog read and analog write. So this is it, guys. This is the basic idea that I wanted to share with you, that how we can use analog functions with the Arduino and use it to control read different values of the sensor, and then we can use the same values to perform some action like just now what we did by turning the brightness of the LED from less to the brightest, and then again vice versa. So yeah, that's it, guys, for today's video. And in the next video, as I said, we are going to take care of the things that revolve around Arduino, like sensors, actuators, current, series, parallel, and many more things. We'll try to cover them, and then we are going to start working with uh, the actual sensors, and we are going to understand how to use each sensor. And as we'll move on, we'll start building complex projects as well. So if you like this video, make sure you hit the subscribe button. If you're new to the channel, hit the like button. If you have any issues, you can add comment at any time. I'll surely reply to the comment. And if you have anyone who is an IoT enthusiast or is interested to learn this, make sure you share the videos with them. And I have recently uploaded the new podcast video, so make sure you check that as well, which is uh, an awesome podcast for those who are interested in mobile application development in iOS. I'll share the link in the description, and also for those who want to buy Arduino and different sensors, I'll leave the link in the description, so make sure you check it out. And that's it, guys. Keep innovating. Thank you. Take care.